So in this chapter, periodicity, what we are going to learn? We are going to learn about the repeating patterns in physical and chemical properties across the period of periodic table. So that could be either atomic size, or it could be either melting point, boiling points. Okay, so we are just going to discuss them. So first of all, let's see about atomic size. If we look at the atomic size of third period, then what is going to happen? Third period is basically sodium with atomic number of 11. Then we have magnesium with atomic number of 12. Then we have aluminium with atomic number of 13. Then we have silicon, 14. And then we have phosphorus, that is 15. Then we have sulfur, that is 16. Then we have chlorine, that is 17. And then we have argon, which is 18. Okay, so these are their atomic number. Let's talk about atomic radius. If we look at the atomic radius, so atomic radius here would be represented in nanometer. So it is 0.157 for sodium. For magnesium, it would be 0.136. For aluminium, it would be 0.125. And for silicon, it would be 0.117. For phosphorus, it would be 0.110. For silicon, it would be 0.104. And for chlorine, it would be 0.099. So we can see, first of all, I just want to describe you one thing, that they are represented in nanometer, okay? And we have seen this thing that as we are going from left to right in period 3, what is going to happen? The atomic size is gradually decreasing, I have not written the atomic size for argon. I will discuss it later in this lecture, okay? So first of all, let's see why the atomic size is decreasing. First point is that we can see that number of protons increases. So what happens when number of proton increases, then nuclear pull towards the outermost shell electrons, which are called as valence shell electrons, that would also increase, okay? As we know that number of protons are increasing, so nuclear pull will also increase. So second point here would be, you can see that number of electron increases by 1. Electrons are also increasing. You can see that sodium is having 11 electrons, magnesium is having 12 electrons, aluminium is having 13 electrons, okay? So number of electrons are also increasing. Is that clear?
Yeah.
Increasing by 1. So new electron, you can see the new electron which has been added in sodium, in magnesium, in aluminium, that is going into the same third shell, or is going into some other shell. What do you think?
Um, it will
Sorry?
go into the third shell.
Yes, they all are going into the third shell because we know that period number also respond to the number of shells. So all are having three shells. Okay, all are having three shell, and electron that has been added up from here, from this sodium to this argon, they all are added into third shell. Okay, so let's write this as well, that new electron that is increasing enter into third shell. Okay, so what will happen because of that? Shielding effect remains constant. Shielding effect, shielding effect remains constant. Why shielding effect is constant? Remember, shielding effect, shielding effect depends on the electron, on the electron present between nucleus and outermost shell. Electron present between nucleus and outermost shell. So you can see that the electron which are present between nucleus and outermost shell, they would remain constant. Okay, outermost shell. Okay, so the electrons remain constant, and because of that, what is going to happen, that their shielding effect would also remain constant. And because of that, what will happen? What
Just
would
one question. So
Gigi?
you know how you said that the electrons remain constant?
Hmm.
Didn't you say that the electrons are increasing?
Oh, just wait. I'm telling you. I am actually talking about the shielding electrons. Let me just tell you what are the shielding electrons. But first, let me write the result for that as well. What would be the result? Result would be greater attractive forces. Okay. Greater attractive forces exerted by increasing nuclear pull. Nuclear pull to the valence electron. Now, your question is that, sir, what are the basically electrons? How you are saying that electrons remain constant? Well, first of all, this is sodium. First shell is having 2 electrons. Second shell is having 8 electrons. Okay? And third shell is having only 1 electron. Okay? So the shielding electrons are the electrons that are present between valence shell. This is valence shell and the nucleus. So how many electrons are present between valence shell and nucleus? So they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that shielding electrons are 10 electrons. Okay. And if we see magnesium, first shell is having 2 electrons, second shell is having 8 electrons, and the last shell is having 2 electrons. So the electrons that are present between valence shell and the nucleus, they are also 10 here. Are you getting my point? So you have seen this thing that shielding electrons would remain constant. So that is why shielding effect would also remain constant throughout this period. Is that clear?
Yeah.
Now, if we are going to draw the graph, like first of all, I just want to discuss about atomic radius. You know that sodium, magnesium, and even aluminium, they are basically metals. Okay, they are metals. So metallic bond is something like this, which is having positive charge, positive charge, positive charge, positive, positive, and positive. Electrons would be there like this. So if we want to find the atomic radius, we would be finding the difference between this point, between center of this point, this cation, and between another cation. So this is basically the atomic radius. Is that clear?
Yes.
Okay. So now, if we want to discuss about, chlorine, Cl2. Chlorine exists as Cl2, okay, in this period. Chlorine makes a bond, covalent bond like this, okay? And if you want to find its atomic radius, then you will have to find the distance between them, okay? And what you are going to do, you are going to divide it by 2, okay? For that, you also need to divide it by 2 to find the atomic radius. And for this, you also need to find it by divide by 2. So atomic radius would be here, that would be, yes, how much would be atomic radius? That is 2 nanometer. If we say this, and if you want to find the atomic radius of a single atom, then you are going to divide it by 2, and that is 1 nanometer. So this is basically the atomic radius of only one atom of chlorine. Is that clear?
Yeah.
But what happens if you want to find out the atomic radius of noble gases, which is group 8? Group 8 is having noble gases. Then what is going to happen? We know this is helium, and there is another helium as well. And we know one thing, that their outermost shell is completed. Okay, their outermost shell is completed, and they are linked with each other by weak intermolecular force of attraction. Is that the same? Weak intermolecular force of attraction. Now, what is going to happen if we have to find its atomic radius? For example, the distance between them is 5 nanometer. And if we want to find the atomic radius, then what we are going to do? We are going to divide 5 by 2, and that is 2.5 nanometer. Is that clear?
Yeah.
Okay. So in this way, you have come to know the atomic radius for noble gases becomes quite high because of these weak intermolecular forces of attraction, that becomes quite high. So if I'm going to plot a graph of the atomic size, this is atomic size. So let's plot sodium, then we have magnesium, then we have aluminium, then we have silicon, then we have phosphorus, and then we have sulfur, then we have chlorine. So we have found the graph would be somewhat like this. It has been constantly decreasing up till this point. And after that, there is argon. So the atomic radius of argon has been increased somewhat like this. Is that clear? If
Yeah.
someone asks you why it has been like this, you can say that because of weak intermolecular forces, their atomic radius becomes quite high as compared to the normal ones. Okay?
Okay.
Okay. So our next one would be atomic radius of ions. Okay? So that is atomic radius of ion in period 3. Okay? So in period 3, this is first group, this is second group, this is third group, this is fourth group, this is fifth group, this is sixth group, and then we are going to have the seventh group like this. So what is happening? This is Na. We know group 1, group 2, group 3, group 4. Group 4 are basically, they are metalloids, which are having both the properties of metal and non-metals. In this one, you have silicon, you have carbon as well, okay? Even you have germanium as well. In this, only carbon is basically a non-metal. All other are metalloids, and metalloids also tends to lose electron. So in group 1, they are going to lose electrons, so it would become sodium ion. And when Mg is going to lose electron, it would become Mg plus 2 ion. It would become plus 3. And here Si would become plus 4. Okay. And
Okay.
for group 5, phosphorus is basically a non-metal. It is going to gain electron and would have a charge of minus 3. Then sulfur is also going to gain 2 electrons having a charge of minus 2. Okay. And then we know chlorine is also going to gain electron. Now, if you are seeing only, like, I just want you to concentrate on sodium ion, on magnesium ion, on aluminium ion, and on silicon ion. So what is going to happen? Sodium here is having how many protons? Protons are 11, but electrons here are 10 after losing one electron. Here protons are 12 and electrons would be 10 after losing two electrons. But here for aluminium, protons are 13, but electrons become 10. So for silicon, it is also going to lose electrons. Protons are 14 and electrons are 10. So if you can view this behavior, there are less electrons, but there will be more protons. In the same way, the proton numbers are increasing for less number of electrons. So can we say that first thing is that from sodium ion to silicon ion, can we say one thing that electrons would remain constant? Would remain constant. But what is increasing? Number of protons are increasing. So what is going to happen because of it? We can say that greater protons are available to attract same number of electrons, to attract same number of electrons. Is that clear? So
Yeah.
because of that, what is going to happen? There would be creating a greater force of attraction, force of attraction. And because of that, what will happen? The atomic radius of you can say first four elements would decrease, would decrease. Is that clear?
Yeah.
So if we are going to draw the graph, it would become like this. For sodium, positive Mg plus 2. For aluminium, Al plus 3. For Si plus 4. So you can see that the graph has been constantly decreasing. Okay?
Yeah.
And now, after that, what is going to happen? From phosphorus, you have seen one thing, that from phosphorus you might have seen this thing, that it is going to gain electrons. It is not losing electrons, so it is going to gain electrons. And in the same way, sulfur is also going to gain electron, and chlorine is also going to gain electron. So what is going to happen because of it? After phosphorus, there would be a sharp, after silicon, there would be a sharp increase in atomic radius, because phosphorus is gaining 3 electrons. Okay. But after phosphorus, what is going to happen? There would be decrease in sulfur. Okay. First of all, this is phosphorus P minus 3. Then we have sulfur minus 2. And then we have chlorine, which is minus. Okay. So this is chlorine. Okay. Why? Why their atomic radius is decreasing? Because you can see that this is phosphorus minus 3, this is S minus 2, and this is Cl minus. It is going to have now how many electrons? It would be having 18 electrons. It would also be having 18, and it would also be having 18 electrons. But number of protons are constantly increasing. So here would be 15 protons, here would be 16 protons, and here would be, you can say that 17 protons. So you can see that for same number of electrons, proton numbers are increasing. So because of that, there would be greater force of attraction. So greater force of attraction starts to build there. And that, what it would cause, it would decrease the atomic radius, would decrease the atomic radius of ion. Is that clear?
Yeah.
Okay. So if we consider about the melting point of period 3 elements, sodium, magnesium, aluminium, silicon, phosphorus, and then sulfur, chlorine, and argon. So if we want to discuss about its period 3 element melting point, then we know first three of them, okay, first three of them, they are basically metals, and they are going to form a metallic bond, okay? They are going to form a metallic bond. But first of all, let's discuss about metallic bond. Sodium is having a charge of positive. Okay, so it is having a positive, it is going to form a cation, positive cation, and there are electrons which are present between them. So you can see that this positive charge cation is going to have this force between this electron. Okay, they are going to have this electrostatic force of attraction between the electrons. So it is having a charge of +1. But in case of magnesium, what is going to happen? Magnesium is +2, +2, +2. This is +2, +2, +2. So it is going to release, more electrons. Okay, so electrons would be greater. So it is having a charge of +2. So it is going to have more electrostatic force of attraction. Okay, greater electrostatic force of attraction. So you have seen this thing in case of aluminium with a charge of, you can say, +3, +3, +3. So it is going to release more electrons and would be having greater force of attraction. This would be having Greater force of attraction. What is that force of attraction? That force of attraction is electrostatic force of attraction. So we have analyzed one thing, that as the charge on metal becomes greater, so there will be greater electrostatic force of attraction. So would be having a stronger metallic bond. So it is having stronger metallic bond. Is that understood?
Yeah.
So it is having stronger metallic bond. So because of that, can we say that its melting point would increase?
Yes.
Okay. But now what is going to happen with silicon? If we look at silicon, you might have studied in your GCSE exams that silicon is going to form silicon dioxide like this, which is having a strong covalent bond. You remember that you have studied about silica, you have studied about diamond, you have studied about graphite. They all would be having strong covalent bonds. Do you remember that?
Okay.
So because of this strong covalent bond of silicon, that would be having more stronger covalent bonds, and it would be having high melting point and boiling point. So if we look at this condition here, if we just look at sodium, magnesium, and you can say aluminium, and afterwards it's silicon. So you might have noticed one thing, that their melting point would be increasing. Their melting point would be increasing like this. Sodium, magnesium, aluminium melting point is increasing because of increasing charge. And why silicon would be having highest melting point? Because of strong covalent bonds. Is that clear?
Yeah.
But now let's move towards phosphorus, sulfur, chlorine, and argon. First of all, if we want to discuss about phosphorus, we must know that phosphorus exists in this molecular form, that is P4. Okay. Sulfur is going to exist in acid forms. Chlorine is going to make a double bond, so it is in Cl2 form. And then we have this argon. Is that clear? So
Yeah.
now, in order to look at its melting point, we have to see how many electrons are present among them. So if we want to discuss about four atoms of fluorine, one is one is having a charge, one is having electrons which is equal to 15. So 4 is going to have electron, we are going to multiply it with 4, so that would become 60. If sulfur, that is having the electrons of 16, and we are going to multiply it with 8, so that would become 128. And if we want to see chlorine, that is 17, so that would become 17 multiplied by 2, so that is 34. Okay. So you might have seen this thing, that their strength would depend upon the number of electrons present. So the greatest number of electrons is present in sulfur. Is that clear?
Yeah.
So the graph would become like this is for phosphorus, this is for sulfur, and this is for chlorine. So it is going to come to become like this, and chlorine has least number of electrons, so its metallic melting point would be at this point. Is that clear? And
Yeah.
for argon, if we want to look at argon, and we know that argon is having weak intermolecular force of attraction, so its melting point would be even less. And even argon is having how many electrons? Would be 18. So you have seen that argon would be having least number of electrons. That is why its melting point would be the least one. Is that clear?
Yeah.
Okay. So the graph responds to something like this. Now we are going to discuss about the periodicity of chemical properties in period 3. So first of all, let's look at the reaction of sodium. So sodium that basically reacts with oxygen and would be forming sodium oxide, that would be forming sodium oxide. So this is in solid form, this is in gaseous form, and this is also in solid form. So we are going to heat it. And first of all, let's balance it out. So it would become 4Na and that would become 2Na2O. Remember one thing, all metal oxides are solid. They are solid. Just remember this thing that all metal oxides are solid. So that is why we can say that sodium oxide is also a solid. So what is going to happen when we are going to put it under the flame? So this is the flame. And when we are going to put this sodium under this flame, then sodium burns with a yellow flame. Sodium burns with a yellow flame. Is that clear?
Yeah.
And then let's move. You have to remember its flame color. It's very important that sodium burns with a yellow flame. And then what is going to happen when we are going to discuss about magnesium with oxygen? It is going to form MgO. Let's balance it. So this would be in solid state. Magnesium exists as magnesium ribbon. This would be in gaseous form and this would be in solid form. Okay. And then this is 4 aluminium plus 3O2. That would be forming Al2O3. That is in solid form. And how it becomes Al2O3? We know aluminium carries +3 charge, oxygen carries -2 charge. So this is a crisscross method. It would form Al2O3. Is that clear?
Yeah.
So remember, both of them, they are basically forming white solids, white solids. And both of them burn with,
Yellow flame.
no, bright white flame. Remember, they both are going to have bright white flame, okay?
Okay.
And we have to keep this in consideration that the reaction of aluminium is quite slow. The reason is that what happens if this is aluminium, it is going to form a layer on its surface. The layer is basically like this. So this layer is basically layer of Al2O3, that is aluminium oxide, and this would stops the further reaction. That is why the reaction of aluminium is quite slow, okay?
Okay.
Because the layer of aluminium oxide is formed on its surface and that would hinder the reaction, that would stop the reaction. So in order to avoid this condition, There is one possibility that we can convert aluminium into powder state, into powder state. Is that clear?
Yeah.
Okay. And the important thing is that we have to keep in our mind all sodium, magnesium, aluminium, they would give a vigorous reaction. Okay. Except the condition I have told you that there's a layer of aluminum oxide would form on its surface and that would slow down the reaction. Okay.
Okay.